Hi, welcome to Mathematics. In our last geometry video, we learned that all two-dimensional shapes have a one-dimensional quantity called perimeter, which is basically the outline of the shape. In this video, we're going to learn that these shapes also have a two-dimensional quantity called area. To help you understand what area is, let's start by imagining a line that's 1 centimeter long. Now, let's imagine moving that line in a perpendicular direction, a distance of 1 centimeter. But while we move it, it leaves a trail, almost like the end of a paintbrush. By moving the one-dimensional line that way, we formed a two-dimensional shape. And all of the space or surface that we covered along the way is the area of that shape, which, as you can see here, is just a square. Okay, but how much area does this square have? Well, our original line was 1 centimeter long, and we moved it a distance of 1 centimeter, so we could say that this shape is a square centimeter. Just like a centimeter is a basic unit for measuring length, a square centimeter is a basic unit for measuring area. But there's other units for area too. For example, instead of a centimeter, what if our line had been a meter long? And what if we had moved it 1 meter? The area we'd have gotten would be 1 square meter. Or what if our line was a mile long and we moved it a mile? We'd have a square mile of area. So just like with perimeter, the units of measurement are very important when we're talking about area. All right, so that gives you a good idea of what area is, but how do we calculate area mathematically? Well, there's some special math formulas or equations that we can use to find the area of different shapes. In this video, we're going to learn the formula for squares and rectangles and the formula for triangles. To find the area of any square or rectangle, all we have to do is multiply its two side dimensions together. They're usually called the length and the width. So the formula looks like this. Area equals length times width. But it's often written with just the first letters of each word as abbreviations. A for area, L for length, and W for width. So let's see if that formula works for our original square centimeter. If we multiply the length, 1 centimeter, times the width, 1 centimeter, what do we get? Well, 1 times 1 is just 1, but what about centimeter times centimeter? Centimeter times centimeter just gives us square centimeters, which we can write like this using a 2 as an exponent. We read this as centimeters squared, and it's just a shorter way of writing centimeter times centimeter. So whenever you see units like centimeters squared, or inches squared, or meters squared, or miles squared, you know it's a measurement of the two-dimensional quantity area. Okay, our formula, area equals length times width, worked for our square. Now let's see if it works for a rectangle. Here's a rectangle that's 4 centimeters wide and 2 centimeters long or tall. First, we plug the length and width into our formula, 2 centimeters and 4 centimeters. Then we just multiply. 2 times 4 equals 8, and centimeter times centimeter is centimeter squared. So according to our formula, the area of this rectangle is 8 centimeters squared. And we can see that's correct if we bring back our original square centimeter. If we make copies of it, you can see that exactly 8 of those square centimeters would be the same area as this rectangle. Great. Let's try our formula on one more rectangle. This rectangle is 2 centimeters long, but only half a centimeter wide. And our formula, area equals length times width, tells us that we just need to multiply these two sides together to get our area. 2 times 1/2 equals 1. So this rectangle is also 1 square centimeter. How could that be a square centimeter? It's not even a square. But just because a shape takes up 1 square centimeter of area, that doesn't mean it has to be a square shape. It just means that the total area would be equal or the same as a square centimeter. You can see that if we break up the rectangle in half and rearrange it, then it would form a square. In fact, we can use square units, like square centimeters, to measure any area, no matter what the shape is. It could be a rectangle, a triangle, a circle, or any other two-dimensional shape. Okay, now that you know how to find the area of any square or rectangle using our formula, we're going to learn the formula for finding the area of any triangle. But to do that, we're going to start with a rectangle again.
What?
The dimensions of this rectangle are 3 meters by 4 meters. So, what's its area? Well, using our formula, we know that the area would be 3 meters times 4 meters, which is 12 meters squared. But now, what if we were to cut this rectangle exactly in half along a diagonal line from opposite corners? It forms two triangles. And because each of these triangles is exactly half of the rectangle, that means that the area of either triangle must be exactly half the area of the rectangle. We already calculated that the area of the entire rectangle is 12 meters squared. So the area of this triangle must be 6 meters squared, and the area of this triangle must be 6 meters squared, since 6 is half of 12. Aha! So the formula for the area of a triangle should just be half of a rectangle. So does that mean that instead of area equals length times width, it should be area equals 1/2 of length times width? Yep, that's basically it, but with one important difference. Instead of L for length and W for width, we're going to use two different names for our triangle's dimensions. We're going to call them base and height, and here's why. The names length and width worked okay for this right triangle because the right triangle is exactly half of a rectangle. But those names don't really work for other kinds of triangles, like acute triangles or obtuse triangles, because how do you tell which side should be which? So for triangles, we do something different. First, we choose one of the three sides to be the base. It doesn't really matter which side you choose, and in a lot of math problems, the base will already be chosen for you. Once we decide which side the base is, we imagine setting the triangle down on the ground so that its base is flat on the ground, like this. Next, we find the highest point of the triangle, which is the vertex that's not touching the ground. From that point, we draw a line straight down to the ground. The line we draw must be perpendicular with the ground. The length of that line from the tip of the triangle to the ground is called the height of the triangle. Oh, some people call the height of a triangle the altitude, which makes a lot of sense if you pretend that your triangle is a tiny little mountain. Sometimes the height line is inside the triangle, like with an acute triangle. And sometimes it's outside the triangle, like with an obtuse triangle. And sometimes it lines up exactly with one of the triangle sides, like with right triangles. But no matter where it is, the formula for finding the area of any triangle is the same. Area equals 1/2 base times height. So if we know these two measurements, base and height, we can just plug them into our formula to calculate the area. At first, you might not see how the same formula could work for all three types of triangles, but watch this. Here's an acute triangle, and this box is 1/2 its base times its height. If we cut our triangle up, you can see that it fits perfectly inside that area. But wait, there's more. Here's an obtuse triangle with a box that's 1/2 its base times its height. Again, if we cut up the triangle, it fits perfectly inside the box. Now you can see how the formula, area equals 1/2 base times height, works for any kind of triangle. Okay, we already figured out that the area of this right triangle was 6 square meters. So let's practice using our new formula to calculate the area of these last two triangles. Our diagram shows that the base of this acute triangle is 5 meters and its height is 8 meters. So we plug those values into our formula for area and we get area equals 1/2 of 5 times 8. 5 times 8 is 40 and 1/2 of 40 is 20. So the area of this triangle is 20 meters squared. Don't forget that the units of measurement for area will always be square units. Okay, that was pretty simple. Let's try our last example. The diagram of this obtuse triangle tells us that the base is 4 inches and the height is 7 inches. So let's plug those values into our formula. We end up with the equation area equals 1/2 of 4 times 7. 4 times 7 would be 28, and then we can calculate what 1/2 of 28 would be by dividing by 2. 28 divided by 2 is 14. So the area of this obtuse triangle must be 14 square inches. Okay, now you know all the basics of area. You know that area is a two-dimensional quantity that we measure in square units. You've learned the formula for calculating the area of any square or rectangle. Area equals length times width. And you've learned the formula for calculating the area of any triangle. Area equals 1/2 of base times height. But don't forget to practice what you've learned by working some problems on your own. That's how you really get good at math. As always, thanks for watching Mathantics, and I'll see you next time. Learn more at mathantics.com.